This is the review for the test. It is important that you know how to do each of these kinds of problems. The first one that we're going to work on is converting among these four different things. Remember that 1 revolution is 2 pi radians, and 2 pi radians is 360 degrees, or pi radians is 180 degrees. And that how you can convert from degrees, minutes, seconds. So let's look at this first one, 1.082802 revolutions. To convert that into radians, well, 1 revolution would be 2 pi radians, so we would have, if we set up a proportion, we would have 1.0802 revolutions. Cross multiply and divide. So on our calculator, we would take 1.0802 times pi, or 2 pi, and then divide by 1, which would be just the same thing, 6.787 radians. Changing that into decimal degrees, we know that 360 degrees is 2 pi radians, or in other words, we could take it times 360 and divide by 2 pi, so, or times 180, oh, we wanted it in degrees, I'm sorry. 1 revolution, I didn't ever write that one down, did I? 1 revolution is 360 degrees. That one I didn't write down. Okay, now we've got it. So we would take 1.0802 times 360 divided by 1, which you don't need to do, and you get 388.872 decimal degrees. Now, to convert that into degrees, minutes, seconds, on our calculator, we have the second function angle button, and if we press number 4, it will convert that to degrees, minutes, seconds to the nearest second, it says. So we would write that as 388.5219. Oops, 19 seconds. Next one. I'm going to change colors for number 2. Now we're given 107.42 decimal degrees. Since they already gave it to us in a decimal degree, let's just switch it real quick. And then second function angle, number 4, and we get 107.2512. Okay. Then switch that into radians. So that number of degrees, we're going to be using this conversion right here, times 2 pi, or we could do it, oh, that's not the right calculator. We could do it 107.42 times pi divided by 180 gives us 1.875 radians. And then the last one is to convert that into revolutions. So we're going to be using this conversion right here. So we divide it by 360. Man alive, I should just get rid of that calculator, shouldn't I? 107.42 divided by 360 gives us about 0.298 revolutions. And then for the last one, I'm going to switch colors one more time, and we're going to convert from radians to each of the different measures. So radians to revolutions here. We're going to divide by 2 pi, 3.775 divided by, make sure you put in parentheses, 2 times pi. Ooh, that wasn't pi. What is pi? Oh, second function pi is 0.601 revolutions. Then to convert it to decimal degrees, 3.775, that's in radians. So we would multiply by 180. We're using this middle conversion factor here, divided by pi. We could have multiplied by 360 and divided by 2 pi, but it's probably easier to do it this way, and we get 216 degrees, 216.292. And then to convert that into degrees, minutes, seconds, angle 4, and it's 216, 17, 30. All right, next one. Find the radius of a circle that has a central angle of 62 degrees intercepting an arc of 18.4 centimeters. Okay, 18.4. Now usually they don't give it to us in degrees. Oops, 0.8 degrees. So if we could take it and change it in by saying a 360 degree circle, that's what we're looking for. What the, no, that would be the circumference. Let's not do it that way. Let's switch this angle into radians. So 62.8 radians, or 62.8 degrees to radians. 62.8. We would multiply by 180 and divide by pi, and we get, whoa, that wasn't right, 62.8 multiplied by pi and divide by 180. And we get 1.0906. Now remember, the formula says that theta equals S over R. So here's the S. We know theta now. So if we take 18.4 divided by our answer, R will be S over theta. Okay, so 18.4 divided by second function answer is 16.78. How many sig figs? I would say 3. Yep, 3 sig figs, so 16.8. Next one. The centers of two pulleys are 24.5 inches apart. Each pulley has a diameter of 6.25 inches. Determine the length of the belt. Okay. So it's 6.25 all the way across. This distance is 24.5. We want to know if you had a pulley at each end, how long the total distance would be. Well, the black part would be, that's the circumference, which is pi times the diameter, plus the red part, 24.5, twice. That will be the length of that pulley. So, 6.25 pi times 20, oops, not times, plus 24.5 times 2. And we get 68.6, 3 sig digs. Next one. Let's see here. Find the central angle that would intercept an arc, in a circle with a diameter of 20 centimeters. Okay, so the arc is 27 centimeters. The diameter is 20, so the radius would be 10. And we want to know what theta is in radians. So it will be S 27 over 10. And we get 2.7. I don't need a calculator for that. 2.7 radians. Next one. How long is the arc that is intercepted by a 131 degrees central angle in a circle with a radius of 9.75 inches? So our central angle is 131 degrees. We have to switch that into radians. So pi over 180 is what over 131. And then the radius is 9.75. Remember that theta equals S over R. Since we know R, we would just multiply by theta to get our arc. So on our calculator, we'll take 131 pi divided by 180, and then multiply that by the radius, and we get 22.3 inches. Next one. The Earth has a radius of 6380. What is the latitude of a city that is 444,490 kilometers north of the equator? Express your answer in degrees and minutes. Okay, so here's our S, 4490. Here's our R, 6380. So our theta is S, 4490 over R, 6380. And that will be in radians. Then to convert that into degrees, 180 degrees is pi radians. Whatever answer we get here, we're going to multiply by 180 and divide by pi. So we would take 4490 divided by 6380, and then take that answer times 180 divided by pi, and then we want it in degrees, minutes, seconds. So angle 4, we would say 40 degrees, 19 minutes, 21 seconds. Although it didn't say to the nearest second, it said to the nearest degree. So we would say 40 degrees, 19 minutes. An arc intercepted by 2.75 radians, central angle is 51.3 centimeters long. What is the diameter of the circle? So in this case, we have a, this is 2.75 radians. Oops, I'm sorry, this is 2.75 radians. The arc here is 51.3 centimeters long. So theta equals S over R. 2.75 equals 51.3 over what we're looking for. And to find that R will be, put the 2.75 on the bottom. So we would press 51.3 divided by 2.75. Now that's what the R is. They want to know what is the diameter, so we're going to multiply that by 2, and we get 37.3 inches? Centimeters. Use your calculator to evaluate each of the following. Let's see here. Pi over 5. So we have to make sure we are in the radian mode. Let's see here. Mode radians. All right. So we take sine of pi divided by 5, and we get 0.5878. It wants 4 sig digs. Cosine 3 pi over 4, so we're going to press cosine 3 pi divided by 4, and we get negative 0.7071, and that would be negative. Tangent 7.1535. Express the answer as though it were radian measure. Okay, so tangent 7.1535, and we get 1.18. Arc cosine, in other words, we want the angle whose cosine is that. So that means we have to press second function cosine because we're looking for an angle. Negative 0.5759 gives us 2.18 radians. So we're in the second quadrant someplace. Next one, express your answer in decimal degrees. Okay, so the angle whose sine, so we want to go back to mode decimal degrees, enter, and we're looking for the sine, so second function sine 0.3507 is 20.53 degrees. And that's all, folks.